Joint variation. A joint variation is a relationship among three variables that can be written in the form y equals k times x times z, where k is the constant of variation. For the equation y equals kxz, y varies jointly as x and z. In other words, when y varies jointly as x and z, y varies directly with both x and z. Now, let's take a look at this first problem. It says that the lateral surface area L of a cone varies jointly as the base radius r and the slant height L. And L, which is the lateral surface area, equals 63 pi square meters when the radius is 3.5 meters and the slant height is 18 meters. Find the radius to the nearest tenth when L equals 8 pi square meters. That is the lateral surface area, big L, equals 8 pi square meters, and the slant height, little l, equals 5 meters. Now, it's not necessary to do this problem, but we might just first of all remind ourselves of what a cone looks like and what these various terms mean. Well, a cone has a circular base, and the radius of that circle is what we call the radius of the cone, or little r. The slant height is this length here. That's our lowercase l. And the lateral surface area is the area around the surface of the cone, excluding the base. Now, it says that the lateral surface area, big L, varies jointly as the base radius r and the slant height, little l. Well, if big L varies jointly with r and little l, that means big L is some constant multiple times r and little l. It tells us that big L is 63 pi when r equals 3.5 and little l equals 18. The reason they need to tell us this information is we need to figure out what the constant of variation is. So to do this, I'm first just going to multiply 3.5 times 18, which is 63. And if 63 pi equals k times 63, if you divide both sides by 63, then k equals pi. Now that we have the constant of variation, we know that the lateral surface area equals pi times r times little l. And we're trying to find little r when big L is 8 pi and little l is 5. Now, if we simply rearrange this right side, pi times r times 5 is the same thing as 5 pi times r. And if 5 pi times r equals 8 pi, that means r will be 8 pi divided by 5 pi. And 8 pi divided by 5 pi would be the same thing as 8 fifths. So that means r equals 8 fifths. And let's not forget our units. So r is a length. So if our measurements were in square meters and meters, the length should be in meters. So 8 fifths of a meter. Now, we were asked to find r to the nearest tenth. Now, 8 divided by 5 is 1.6, so I'll also write our answer as a decimal, 1.6 meters. Okay. Take a moment, pause the video, and see if you can do problem number 2. Number 2 says the volume of a cylindrical can varies directly with its height and the square of its radius. So, first of all, a cylinder looks something like this. We have a cylindrical can. And it says that the volume of the cylinder varies directly with its height and the square of its radius. Another way of saying that is that the volume varies jointly with h and r squared. So here's another example of a joint variation. 2a is said to write a variation equation. That's what we've done here. Now it says to solve for the constant of variation. To do that, we need to use this information that the radius is 3.2 centimeters when the height is 11.1 centimeters and the volume is 357.1 cubic centimeters. So, let's solve for k. I'm just going to do some arithmetic on the right side. I'm going to do 11.1 times 3.2 squared, which equals 113.664. That equals 357.1. So k equals the 357.1 divided by the 113.664, and when we do that, we get about 3.142. Now, perhaps it doesn't surprise you that that number is pretty much looks like pi, and in fact it actually is. You may recall the formula for the volume of a cylinder is the area of the base, which is pi r squared, times the height. So in this case, the problem was obfuscated, if you will, in order to practice finding the constant of variation, but perhaps you may have known from the beginning that the constant of variation actually is pi. Now 2b says to find what would the height of the can with the same radius need to be to hold 524 cubic centimeters. So this was part A. Part B, we're trying to find h when the volume is 524. So we have pi times the same radius as before, which is 3.2, and we're trying to find h. So I'll first just square the 3.2, which is 10.24, and I'll write this as 10.24 times pi times h equals 524, and h would be 524 divided by 10.24 pi. And I'll go ahead and get a decimal approximation for this. 524 divided by 10.24 times pi is approximately 16.289. And if we go back to our units, you'll notice that these lengths were in centimeters. The height is a length, so this would be in centimeters. So, to recap, in a joint variation says that one variable varies directly with two or more other variables. Whenever we have any sort of variation, we will have a constant of variation. The first thing to do in these problems is to write a variation equation, which will involve all of our variables and have k in the place of the constant of variation. Then we'll have to use whatever information we were given in order to find the constant of variation. Once we know the constant of variation, we can substitute that into our variation equation and then solve for whatever it is that we need to solve for.